Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, students? This is a summary about chemical calculations in chapters 5 and 6. First, AR, the relative atomic mass. What is meant by relative atomic mass? It is the average mass of naturally occurring isotopes of an element relative to the mass of carbon 12 atom. So carbon 12 atom is the standard and its atomic mass is 12. And we compare all other elements to carbon 12. So in general, what is atomic mass? It is the average mass of the isotopes of some element. For example, here we have chlorine. Chlorine has two isotopes, 35 and 37. 75% of chlorine found in nature is chlorine 35, and the 25% of chlorine in nature is chlorine 37. So how to get the average? We multiply the percentage 75% times the atomic mass 35 plus the percentage 25% times the mass 37. In this way you get the average mass, the atomic mass of chlorine, which is 35.5. After this, the moles. What is meant by mole? Mole is the relative atomic mass or relative molecular mass in grams. If I talk about atoms, we say relative atomic mass. If we talk about molecules or formula units for ionic compounds, we say relative molecular mass. One mole actually has a constant number of particles. This number 6.02 times 10 power 23, and this is called Avogadro's constant. For gases only at room temperature, which is 20 Celsius degrees and 1 atmosphere, the volume of 1 mole for any gas is 24 cubic decimeters or 24 liters. So to answer questions in chemical calculations, you need to know these laws. First, the number of moles equal mass over the mass of 1 mole, and the number of moles also equals the number of particles, atoms or molecules or ions, over Avogadro constant. And for gases only at room temperature and pressure, the number of moles equal volume over 24. For solutions, if you want to know the concentration of the solution equals the number of moles of solute over the volume of the solution. The volume of the solution is measured in liters or cubic decimeters, and the unit of concentration is mole per cubic decimeter or molar or m. For titration questions, if you do titration of acid against base, you have the acid in the burette and the base in the flask, or the opposite, you can put the base in the burette and the acid in the flask. The law you use here is CV equals CV. Concentration times volume for the acid equals the concentration times the volume for the base, but you should divide over the coefficient in the equation. And for example, if you have HCl reacts with sodium carbonate, so they react together to make sodium chloride, water, and carbon dioxide. Here, when you balance this equation, you put 2 here, and you put 2 here. So you have 2 hydrogen, carbonate the same, and 2 sodium. So now the coefficient here, you have 2 with the acid and just 1 with the base. So this coefficient, you put it in the equation. For the acid, the coefficient number here is 2, you put it here, and for the base, the coefficient number down here. So using this law, we can calculate concentration or volume in titration. Right now, we can have an example. Of chemical calculation. This is here the past papers. June 2016, paper 2, variant 1. Here he gave us a compound X contains carbon, hydrogen, and oxygen, and he needs us to know the molecular formula. How to do this? We have steps. First, you have carbon, hydrogen, and oxygen. This percentage You can put it as mass: carbon 40, hydrogen 6.7, oxygen 53.3. Then write the relative atomic mass from the periodic table. Then get the number of moles, divide the mass over the relative atomic mass. Then put the ratio between the number of moles of carbon to the number of moles of hydrogen to the number of moles of oxygen. If you don't get whole numbers, in this case, divide over the smallest number to change this ratio into whole numbers. So we get the empirical formula. Empirical formula means it shows the simplest ratio of atoms between elements. So here CH2O. After this, if you want to get the molecular formula, calculate the mass of the empirical formula. It's 30, and he says here the mass of the molecular formula is 60. So molecular formula is the double of the empirical formula. So multiply the empirical formula times 2 to get the molecular formula C2H4O2.